Okay guys, so welcome back. We have a PowerPoint here on expanding binomial expressions. So first things first, what is a binomial? A binomial is an expression with two terms such as x plus 5 or x squared plus 3. So the product of two binomial expressions can also be expanded using the distributive law. So we saw the distributive law in action a couple of PowerPoints ago when we first looked at expanding. So this involves multiplying every term in one expression by every term in the other expression. Great, so let's have a look at an example of what that means exactly. Now, one really nice way to have a look at the binomial expansion is to investigate the area of a rectangle. Now, we have a rectangle over here, and we can see that the length is this little x distance here. We don't really know how long x is, okay? But it's not just x, but it is 2 longer than x. So what we can do is we can think about the length of this side as being x plus 2. And then the width, or this side length, is very similar. It is x long, but also has this little bit 1 tacked onto the end of it, okay? So it is x plus 1 by x plus 2, and we've written that over here. So if x plus 1, okay, and x plus 2 are the side lengths of a rectangle shown, we are going to write an expression for the total area of the rectangle using those lengths there. Now, we've all seen the area of a rectangle written before. The formula is length times width. And for our particular problem, well, our length, as we just said, is x plus 1. And we're going to times that by x plus 2. Cool. So, what does that mean? How are we going to calculate x plus 1 in brackets times x plus 2 in brackets? This is our binomial expansion. Now, before we get into the method that we're going to learn today, we need to kind of break it down into bite-sized pieces that we can manage without it. So there's a really nice way that we can check our answers and check our method to convince ourselves that it works. And we do that by breaking down each of these little shapes in here. So if we come back to our diagram over here, we can see that it's broken up into 1, okay, 2, 3, and 4 little areas. And then the area of our total shape is the sum of those 4 areas. And so what we have written down the bottom here is we have our length, we have our width, and what we've done is we've said, well, the length times the width is going to add together to give us this great big total area. So let's calculate the little areas first and add them up and see what happens. So we already have area 1 together, so we had x times x, and this is area 2, so it is going to be 2 times this length, which is x, okay, x over here. So 2 times x is, of course, simply 2x. We can add on area 3, which is 1 times x, which is just x, there we go. And then area 4 is going to be this side length times this side length, 1 times 2, which is 2. Of course, we should fill in this gap, make sure it's all complete. So this was our other side length. Fantastic. So we could tidy that up a little bit because we have some like terms. Hopefully you guys spotted that as well. We of course have x squared, okay, that's all by itself. But we have 2x and we have 1x, okay? They are like terms. They both only have 1x. Like terms like to be together. So if we have 2x's and I add one more, okay. So what we just saw was our box method or rectangle method, and it allows us to keep track of all the different terms that we are going to get when we expand our binomials. Now, drawing boxes might not be your thing, so what we have is another method called the FOIL method. Now, the FOIL method is a really nice way for us to keep in mind all the different multiplications that we need to do whenever we expand our brackets, our binomials, to make sure that we don't forget any. So, first, we multiply together the first terms in each bracket, and we can see that the blue, okay, first is in blue, and it corresponds to our blue line over here. So this number here is left blank, okay, but you could imagine that there would be a term in here for the binomial. There would be a term here, 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 and here, just like we saw with our lengths and widths before. Now the blue one, we multiply the first terms together in both sets of brackets. Second one is our outer, so we multiply together the terms on the outside of each bracket. These ones here. Third is our inner. We multiply together the terms on the inside. Okay, so these two ones that are really close. And then the last ones. We multiply together the last terms in each bracket. Okay. We need to make sure we multiply every term in one set by every term in the second set. FOIL helps us remember all of them. Let's have a look at what it looks like as an example. Okay, let's have a look at an example. This is the binomial we are going to expand. Okay, and what we're going to do is we're going to follow our FOIL. So we multiply our two first terms together, and then we multiply our outer terms together. So let's do those two first so we don't get too confused. So I have my first term, so I have an x times an x, and then they're all positive, so it's going to be a plus. My outer terms, so my x times 1, and then I do my inner terms, okay, plus 2 times x, and then I do my last terms, okay, plus 2 times 1. Of course, we always like to simplify. We like our answers nice and simple, so we can tidy this up quite a little bit actually. X times x, so we can write that as x squared. X times 1, well that's just 1x. 2 times x, so that is 2x. 2 times 1 is of course 2. And this might look familiar to you because it is exactly the same as our box question. And what we had in our box question was a couple of like terms. We had some x's here. So let's tidy that up. We'll group our like terms. Bob's your uncle. Happy day. Okay, I do. Let's have a look at another example. Again, we are simply going to expand this binomial. We'll use our FOIL method. Maybe I'll show you guys how to do the box method as well, in case you're that way inclined. So, first terms first. Oh, let's get rid of that. X times x plus. I need to do my outer terms, so one's on the outside. I have x times 5. My inner terms plus 3 times x, and then my last terms plus 3 times 5. Tidying that up, x squared plus 5x plus 3x plus 15. Let's group those like terms again. X squared's all by its lonesome. 5x plus 3x is more. I have 8x plus 15. Okay. Very quickly, I'll show you guys how we might set it up using that box method. Ooh. Let's draw a better box than that. Cool. Now, let's have a look. So we have, this can be x plus 3, x plus 5. So this is like our example at the start of our lesson. And what we're going to do is we are going to calculate the area of each square. So this area is going to be the x times the x squared. This little area over here is going to be the 3 times the x, which is 3x, and this one 5x, this one 15. The total area, okay, or the two sets of brackets multiplied, is going to be the sum of the total areas, sum of all four terms. So let's go ahead. 3x plus 5x plus 15. And surprise, surprise, we get exactly the same answer. Guys, take your pick, okay? You'll find that the first FOIL method, okay, a little bit more straightforward, but the second method might help you understand it a little bit better. Completely up to you. Maybe the bottom one, this box method, very good for learning. This is what we're aspiring to, okay? So if you're happy with this, definitely stick with it. Another I do, okay? And a little bit tricky now. The one thing that stands out to me, have a negative. Nothing to be scared of. We'll just follow our FOIL and see how we go. First, x times x. Outer, we have plus x times 7. Inner. Now what I like to do here is I still like to add it, but it's going to be negative 4, okay, times x. And then our last, minus 4 times 7, simplification time, x squared plus 7x minus 4x, okay? So that's where that minus comes in there. And of course, oh, said I'll have my plus there and I forgot it. Plus, minus 28. One more simplification step. So 7x, I take 4 away. I'm left with 3 x's, take away 28. Process doesn't change. The one thing to be on the lookout for, okay, is that multiplication of negative numbers. So we have to be on our toes, but as I said, the process is still exactly the same. Rightio, we do time. I'll give you guys a bit of a head start. If you guys would like to have a go at this yourselves, pause the video, have a go, come back once you're finished. See you soon. Okay, hopefully we're unpaused and welcome back and see how you went. So, expanding it all out, okay, we've got our first, outer, inner, last. So notice we had to be a little bit careful. We had 2 negatives, okay, and of course negative times a negative gives us a positive on our last one there. Okay, so hopefully you guys were on your toes there and spotted that one. Of course, the next step there is to group our like terms. Negative 11, take 2x, negative 13x. It's negative 11 degrees, it gets 2 degrees colder, negative 13 in total. So keeping in mind all those positive negative tricks that we've learnt over the past couple of years. Rightio guys, what we're going to do, we're going to have a crack at a couple of you-dos. So, you know the drill. If you can pause the video, have a crack, come back, and we will check our answers in a few minutes. See you soon. Okay, and welcome back. Now, don't have a whole lot of room for working out, but, okay, if you're unsure, you can click back a few minutes, second or two, and check out the process, because the process doesn't change. FOIL, first, outer, inner, last. I'm going to simplify it all together in one step if that's okay, because this is our you do, you are checking, you're working. Hopefully that's what you got. Okay. Well, let's put these in, otherwise I kind of lose track of what I'm doing. X times x plus, so 3x plus 4x, 7x plus outer, sorry, the last 3 times 12, 4, excuse me, getting ahead of myself. 3 times 4 is 12. Got a couple of a's, same thing, a squared plus, so I'll have 8a, so a squared, a times 9, 8 times a, 8 times 9. So I'll have 9a plus 8a, which is 17a. I need to remember my times tables. That seems about right. First, outer, inner, last. P squared plus 14p plus 48. Now, some of you guys might be paying particularly close attention, might have started to pick up a bit of a pattern. So if you found the pattern, maybe you might like to put it in the collaboration space. We can have a bit of a talk about it there. At the moment, pretty happy for all of us to keep putting in all of our working. Obviously, I'm not doing the working here. I ran out of space, but you guys, I would expect to still be doing the working. X squared, and I'll have negative 2x plus 9x, so I should still have 7x's there. 9 times negative 2, so I have a positive and a negative. My answer should be negative. 9 times 2 is 18. Hopefully that looks good. Okay, go back, have a check. If you may be getting some things not quite right, as I said, go back, have a look at some of the I do's and make sure you are foiling. Again, another couple of you do's. Like before, guys, I'll give you yourself about 5 minutes, pause the video, come back when you're ready, and I'll see you then. And welcome back. Let's see how you went. Same thing, guys. I'm just going to run through these answers. I'll put in my FOIL lines and just see how we go. X squared minus 8x plus 10x. I should have plus 2x. 10 times minus 8 is negative 80. Righto, here we go. X squared minus 3x minus 10. Cool. A squared plus 5a plus 8. Oh, hang on. Let me just do that in one go. 13a plus 40, getting into a bit of a rhythm there. But yeah, look, hope everyone's well. Hope we're isolating, washing our hands, particularly you, Hamish. Don't want any cow things on them. There we go. And a couple more. Minus 7x plus 12. Okay, x squared minus 9x plus 20. That's it. Good as that, guys. FOIL, first outer, inner last. First outer, inner last. Works every single time. Those negatives can get a little bit tricky to keep track of. Okay, you might notice that there's a bit of a pattern. As I said, keen to see if you could spot it. See how you... Okay, so the difference of two squares. Now, seems like a silly thing to say, but this is actually one of my favorite binomials to expand. We have a plus b, and then the same a value, but it's subtract the same b value. Now we have the rule written out here, and I'm going to really quickly show you why we simplify it down to this really nice solution. This is something to keep in mind, but I don't think I would commit it to memory. I think if you can FOIL it out, that will be good enough. So let's have a look. Let's do a little bit of working out over here. If we do a plus b and a take b, well, we FOIL first, outer, inner, last. So first, well, that's a squared, a times a. And then I have outer, so a times minus b. So I have plus a times minus b. And then I have the inner, so b times a. And then the last, so plus b times minus b. Let's tidy all that up. A squared, so I've, oh, hang on, I got a minus here. So I have plus minus ab plus, excuse me, ab minus b squared. If I have minus ab plus ab, I have a bit of cancellation here. And I end up with a squared plus minus b squared, or I probably don't need that minus. Look familiar? Really nice result. If you remember it, or you can identify that that's what we have going on, fantastic. If you don't, no problem, you can FOIL it out as normal and get the exact same result. Rightio, what we're going to do, we are going to do a couple more you-dos. So I will leave you to it, come back in a few minutes, and we'll compare our answers. Okay, welcome back. Let's smash through these. I'm just going to use the rule. If you FOILed out, fantastic. Not too stressed about that at all. So what we're going to do is we're going to have x squared, and that's going to be minus 9 squared. Already did the 3 squared. X squared minus 12 squared. A squared minus 25. X squared minus whatever 15 squared is. X squared minus, what's that, 121. And x squared minus 100. Okay guys, that's it for today. Have a look over it again if you need to. Have a crack at that worksheet, and I'll see you next time.